a couple of times. We will have to make sure that we stay thorough with that. And again, before I start the class, Dhanushree, I'm giving this responsibility to you, beta. The second topic that you are given to me. Tomorrow you will ping me, call me, message me, whatever it takes, okay? And you'll not leave it till you are able to talk to me, okay? So that we do it tomorrow for half an hour, 45 minutes, only one-on-one with you, and we'll make sure that at least we have a good conceptual understanding of how we're going to talk about fundamentals of algebra. Yeah? Sure?
Yes, sir.
Okay. Alright, so let's get started. I know some of you are still missing. Here, Slavia is missing. There are a few new students also supposed to join, but it's okay. We can get started. So I said we'll talk about, let me repeat the day of the topics for today. Evaluating functions, composite functions, graphing functions, isolating quantities, linear and quadratic systems, and radical, rational, and absolute value functions. Let's see how much we are able to cover today. So when you say evaluating functions, first of all, is everybody clear about functions? I know Pranit has heard it enough. Athar would be sure. Dhanushree would have heard it enough from me. But Shivatsa also has heard. So Baba also is well versed with it. So we'll do more of a practice lesson of talking. Okay. So when you say functions, these are something that you relate with your real life, right? We have a Diwali function, we have Ganesh Chaturthi function, we have Dandiya function, we have Eid Ramjan function. These are functions or events. And why do we call them functions? Because there is an outcome. For people like me, who is foodie, goes to all these functions because there's an outcome, which is food, right? So every function when you talk about, it has an outcome. You do something, you go well dressed, you put on nice clothes, you go do worship and be part of the culture, and then outcome is food. Same way, when you look at function, this is your input, this is the investment you do, this is the dress you wear, this is the money that you spend, and then this gives you this as output. If you give X, meaning if you go well dressed, you go on time, you get food. So when you look at a function is nothing but it's a relationship that is depicted in this form. You have an expression. When you go and meet the host, you smile, you have an expression here, and the host gets happy and gives you food. Right? That's how I went to your place with a smile on my face and I got dinner. Yep, on Ganesh Chaturthi. So that is how you can relate. Correct? So when you look at a function, in simple terms, a function is nothing but an expression, and when you give a value to the expression, it becomes a function. Or in simple day-to-day life, you will see that there are functions which you can replace as, okay, fine. I don't want to write something cryptic like this. I will say y is a function of x and the value of y is dependent on this. This is your function. Okay? So if you look at the function as a whole, it has following things. It has an expression which will give you an output, and this whole thing is dependent on a relationship. Okay? Here you can read this as y is a function of x and the value of y is equal to this. Now, this part is clear, right? All the funny stuff, all the bad analogies that I gave, relatable? Okay. Now you will see different things coming across. One, you will see something like 3x plus 7. I don't know why 7 is my favorite, but I keep on writing 7 on the board. and then you will see something like, or let me not deviate from function. I will keep on writing function so that it doesn't look like I am not honoring my promise. So this is my one function. Here y is a function of x and the value of that is this. Similarly, I can also have other function which I'll say, okay, that is function of x where the value of y is equal to, let's say, 3x squared plus 2x minus again 7. No, 9. So these are two examples of functions. What is the difference between this guy and this guy? Anybody?
One is quadratic, one is linear.
This is a quadratic function and this is a linear function. Everybody with me?
Yes, sir.
Neil, Sarah?
Yes, sir.
Okay. Why this is called linear function? Because when you use this on a coordinate plane and draw this, it will draw a straight line for you. That's why this is called linear function. It draws a line for us. Similarly, when you talk about this as a quadratic function, this is called a quadratic function because here in this function, if you see, the maximum power to the variable is 2. So when you have any function or equation written like I'm purposefully trying to write which doesn't have a 7, okay? So when you see an equation or a function where the maximum power to the variable is 2, that is called a quadratic equation or quadratic function. Okay? I see one new student in the class today. Hello, beta. Can you tell your name and which grade you are in? Harsh. No. Is it Harsh or Hitesh? Okay. All right. He dropped off. So that's fine. So what I'm saying is, when you see an equation like this, or you can call this an equation when you don't put the fx. When you just write it like this form, you can call this an equation. If you put an fx, and then you can relate that with a function. Hello, beta.
Yeah, sorry, my bad. My mic wasn't working.
That's okay. What's your name?
Inish.
Inish. Okay. And you're in which grade? 9th grade. So I believe it's Lalita ji is your mom, is it?
Yeah.
Yeah. Okay. So she had reached out to me, and I know you wanted to join for a geometry class, and this is not a geometry class alone. We learn anything and everything that we need to prepare for SAT. So geometry will be a part of it. So today we are not doing geometry, but no, in the subsequent classes we'll do geometry. Sorry, I'm pronouncing it the Indian way. All right. So today we are doing algebra. We are talking about functions and all. So let's see how much you're able to follow me, how you're able to learn from the class, and if the learning becomes fun, obviously we'll continue together. Yeah.
Okay.
Yeah. All right. So we are talking about different types of function. This one we are calling as a linear function or a linear equation, whatever you call it, because this draws a line for us. Similarly, when you look at a function like this, where the maximum power to the variable is 2, that is called a quadratic equation or quadratic function. When you write like this, you call it a quadratic function. When you write it like this, you call it a quadratic equation. Yeah. Basically, when you don't have this, you call it a quadratic equation. Okay. So now, why quadratic equation? Meaning any equation or a function where the maximum power to the variable is 2, that is called a quadratic equation. Now everybody in the class would probably be knowing that if we try plotting a quadratic equation on a coordinate plane, it draws a parabola. Yeah. If we plot a linear function on the screen on the coordinate plane, it draws a straight line. That's why it's called a linear function or linear equation. So the topic that we are going to cover, first thing, let's look at evaluating a function. That's the simplest of the thing that that we need to know and that we can relate to. So let's look at evaluating a function. What does it mean? You'll be surprised to know that even in SAT exam, people say, okay, I have a function like this where it is stated as, let's say, 5x squared minus 7y plus 7x plus 20. Evaluate this function for value of x equal to minus 2. Do we know what does it mean? Evaluate this function for a value of x equals to minus 2. You know it? Anybody in the class who doesn't know? Is an opportunity for me to teach. Neil, Sarah, have you seen this better before? Do you know how to evaluate a function for a given value of x?
Yes.
Wonderful. How about you, Neil?
Yeah.
Okay. So, can everybody take 30 seconds and tell me what is the value of this function for the value of x equals to minus 2? 30 seconds to 1 minute, not more than that. And I will just wait for 2 responses and then we'll do it. See this is AI. I just said this and it was showing balloons on the screen. Okay. Yeah, whoever is ready can raise the hand and tell me what the value is. I just need 2 answers. Yeah, Baba, how much it is?
54.
54. Okay. 54. Okay, I got 2 answers. I know it's easy peasy, so I'm not going to wait for everybody else. But as you all know, right? I'm a very bad guy. I don't trust anybody when it comes to maths. I will just do it, and you guys can see how do I write my story. Okay. So we have to evaluate this for x equals to minus 2. Meaning, this question says evaluate this function for x equals to minus 2. Okay, fine. So x equals to minus 2. What I will do is, wherever I have an x, I will put a minus 2. Wherever I have an x, I will put minus 2. As simple as that. So this becomes 4, 5 4 are 20, minus 7 into minus 2 because plus 14 plus 20, 54. Now I can trust my and finish both. Okay. So I did not do anything magical here. Any function that you have and you have been asked to evaluate it for a given value of x or y. I mean, if it's written as, let's say, function of x, a function of y is by 5 always. 20y squared minus 2y plus 22. Evaluate this for a value of y equals to 3. It's very simple. I will just substitute the value of 3 wherever I have y, and that gives me the value for the function, or that is all about evaluating function. Okay, so I'm not going further into that. Is this part okay so far? Everybody is okay? Okay. And let me know when you guys get tired, okay? Because I keep on repeating myself. I know even if it's something easy, but then if I do it again and again, it becomes easier for all of you, right? Now next thing is composite functions. What do you mean by composite functions? Anybody? Just give me the layman's definition of a composite function. Anybody? Can I assume you guys don't know? Or you guys are just being shy? What is a composite function?
I don't think anyone knows.
Okay. Including me. Okay, bad joke. Alright, so Srivatsava, do you know what is a composite function?
No, sir.
Okay. Then that's an opportunity. Dhanashree, have I not taught composite function before? I'm just trying to recollect. Yeah, Vaibhav.
Sir, it's a function that is written inside the other function.
Yeah, that's what I was wondering whether I've taught this before or not. But anyway, let's do it.
Yeah, we've done composite functions before. Sorry, it wasn't letting me unmute, so I couldn't talk.
Okay, not a problem. So again, just we'll go through that very quick. So when you say composite function is nothing but a function of function. Okay, meaning if I have a function like this is a function of x. Okay, let's say this value is, this time I'll make sure there is no 7. Okay, 2x cube minus 5x square. Okay, this is my one function of x. Now I have, let's say, another function called g of x, which is, let's say, 5x minus 2. Here, if I ask you guys, evaluate this for x equals to 3, that is fine. If I say evaluate this for x equals to 3, that is also, or 3 or 2, whatever number I say, that is also fine. Now, the fun begins when I say find out f of g of x. What does it become? I have a function of x with this equation or this representation. I have a function of g with value as this. If I say function of g of x, this is a classic example of a composite function. This is function of function. Okay, function of function. So, sorry, this is function of function. This is my function, and inside that, it's not function of x, it's function of another function. So here, see what's up, everybody is able to follow me, right? I'm just checking, okay?
Yes, sir.
If I have these two functions given, and if I'm being asked to find out function of function or composite function of g or f of g for x, what that would be? Does anybody know? Yep.
With x, you would find g of x first,
Mm-hmm.
and wouldn't that be what x is for f of x?
Right. So it is nothing different from what we did so far when it comes to evaluating functions. Okay. So if I have to find out f of g of x, that means instead of earlier we had x, now instead of x it says put another function. It's like a nesting. Okay, so this is like your child, this is a parent, and this is a grandfather now. Okay, so it's like a family tree that is talking about. In simple words, instead of x I have a gx. So what it would mean is wherever I have x I will put a gx. As simple as that. That means here now function of g of x. Function of x is 2x cube minus 5x square. So wherever I have x, I will put a gx. So this will become gx. 2x cube. Instead of x, I have a gx here. Minus 5 into x. In place of x, I will have a gx square. Now, you know what is the value of gx that is coming from here. So that would become 2 times gx is 5x minus 2. Cube of that minus 5 into 5x minus 2 square of that. So now you have to find out the cube of this and square of this and break the brackets and then you put them together. That's what becomes your new value. Is this part okay so far? Neil, Sarah, Sivatsa?
Yes, sir.
Here. So even if somebody says composite function or function, okay, the only thing that we have to keep in mind is function is nothing but a relationship. This is a relationship. It says function of x. So when you say function of x, let's say I will say my saving is a function of my salary, meaning if I get more salary I can save more. If my salary is less I can save less. So that's what it is in real life. So here also it says so how much I will save is related to how much I earn. Correct? So that's a relationship. I cannot say that I will earn $2,000 a month and I will save $20,000 a month. That is not possible. So that's a relationship which you cannot break. Now here, this is the relationship given. Say, okay, function of x, which will translate to y, some value, is dependent on this relationship. Now when you say composite function, you are just saying that, okay, function inside a function. That's it. So instead of x, you will have a function. So whenever you have to find out the value for composite function or evaluate a composite function, you just have to kind of look at both the functions and see which one is the parent. And inside the parent, how will you place the child and break it down. Is this part clear? So when it comes to composite functions, you don't have to kind of stress out. It's the same stuff with a different package. Meaning instead of x, you have another thing. It's like when I was small, we were 5 siblings. Everybody, we had mom, dad, and then 5 siblings. Now, when we have grown up, we all have our own kids, right? So same thing here. This was the child before, which had graduated to become a father now, and he has his own kids. So these kids are here, right? So you will just replace it here. It is still part of the same family, but you are just plugging in the new value for the kids. Earlier I was one person, now I'm a family of 4. So instead of 1, I will put 4 here, correct? So that is how it will be, yeah? Make sense? Alright. So that is how you will look at composite function or functions. Don't stress yourself out that this is something very complicated. Though the name says composite, but there is nothing so very funky about it. Okay, it is only to give a different flavor to our understanding of things. Now comes the next one, which is called graphing a function. This is another fun event that you can always do when you are dealing with function. So can I assume that everybody in the class is comfortable with the coordinate planes? Everybody? Including me? Yeah. And sometimes you'll have to bear with me for my bad jokes. My kids call it dad jokes. Yeah. I'm sure you guys deal with it at home as well. So this is the coordinate plane. Let's say I have a linear function. Linear equation of function. Let's put a linear equation for now so that I don't keep on confusing you guys. In the background, you can assume wherever I have a y, you can assume that is fx, okay, function of x. So here, if you read this, y is a function of x. Let's say I say 4x minus 22. Here you can assume y is a function of x, right? And then this is the relationship. This is the agreement. This is a contract between x and y. I'm saying this is a linear function, linear equation, meaning to draw a straight line. So how you have to graph it? I know some of you must be thinking that's a waste of time because you guys know it very well. But I'm just doing it for the sake of revision, okay? Let's say this is 2, 4, 6, 8, 10. This is minus 2, minus 4, minus 6, minus 8, 2, 4, 6, 8, 10, 12, minus 2, minus 4, minus 6, minus 8, minus 10. Okay. So when you have to plot this, I'm saying it's a linear equation. So it will draw a line. Let's assume that it's a linear equation for now. And draw a line using this one. Or don't assume anything. What you will have to do is build a table quickly for x and y value. And then that x and y value becomes those coordinate points for you. And when you look at any equation like this, always remember this is a contract. This is a contract between x and y. It says that if I add the value of y and value of y is equal to 4x, 4 times the value of x minus 22. So this is a contract. If you increase the value of x, the value of y also increases. If you decrease the value of x, the value of y will correspondingly decrease. So this is an agreement. When you look at an equation, look at that as an agreement between the variables. There are two variables, x and y. This is an agreement. So let's find out when I put x equals to 0, what will be the corresponding value of y? X is 0, y is minus 22. Okay, fine. Let's put x equal to 5. If I put x equals to 5, what will be the corresponding value of y? Minus 2. 5 4 is 20, minus 22, so minus 2. If I put value of x equals to, let's say, 10, and we can choose that. We can build this table by ourselves. We just have to make sure that we plug the value and get the corresponding value of the variable. If I put value of x is 10, 40 minus 22, it will be 18. So now we got 3 points. Let's see if we can use these 3 points to draw the line. So 0 and minus 2. 0 and minus 22. So 0, x is 0, so it will be somewhere on the y-axis. Minus 22, it will be somewhere down. Let's say this is 22. Okay. So I will change this. 4, 8, 12, 16, 20 and 24. So this becomes 4, 8, 12, 16, 20, 24. I'm just changing the scale so that we can draw it. So now 0 and minus 22. So it will be somewhere here. This point. This is my 1 point. 5 and minus 2. So when x is 5, y is minus 2. So it will be somewhere here. This is the second point. Third point is when x is 10, y is 18. When x is 10, y is 18. So it will be somewhere here. So join these 3 points. This will draw the line for us. So usually if you are drawing a line, you just need 2 points. Here I went a little overboard. I picked 3 points to draw the line. But any which way, remember this is a contract between x and y here. Even if you pick 4 points, you will find that all those 4 points will lie on the line. You have to just pick 2 points to draw the line anyways. But when you join them and then you find other points, you will see that those points are also falling on this one. Okay. So this is just for plotting the graph. Nothing great about it. Very simple concept. I have not done anything fancy. I just use this contract to find the points and draw it. Neil, Sarah, here, everybody. You would have seen this 100 times, but I just did 101 time. Okay. Yep. Everybody is clear about this part, right?
Yes.
Now, if I have a linear equation, that is easy, fine. I can find the points and draw the line. What if I have a quadratic equation? Let's say this is not a linear equation or linear function. I have an equation or function like this, which says y equals to x squared minus 6. Now this is a quadratic function or quadratic equation because the maximum power to the variable is 2. So here also the same thing. You don't have to do anything different. Same thing, you find out x and y value, because when it's a equation or a function, this is nothing but a contract between the variables. You will have to find out for every value of y, corresponding value of x or vice versa. So here also again, You always, let's say, when x equals to 0, what is the value of y? Y is minus 6. When x is 2, what is the value of y? Y is 2 to the 4 minus 2. When x is 3, what is the value of y? 3. 9 minus, yeah. When x is 4, 16 minus 6 will be 10. So we got 4 points. Now, since it's a quadratic equation, it will not draw a straight line for sure. It will draw a parabola that we know with experience, but that's why I'm picking 4 points. Otherwise, if you just pick 2 points and join them, it will look like a straight line. Okay? So here, if you see 0 and minus 6, 0, x is 0 and this is minus 6. It will be somewhere here. This is 1 point. 2 and minus 2. When x is 2, y is minus 2. So this is second point. 3 and 3. When x is 3, y is 3. Somewhere here. When x is 4, oops, sorry. 3 and 3 is somewhere here. When this is 4, this is 10. Somewhere here. So, since I picked only 4 points on one side, see this is what it is drawing. If I would have picked some negative value for x also, it would have drawn something like this. Okay. So this is about graphing a function. Meaning when it comes to graphing a function, what you have to do is you have to find out as many points you want. Okay. And to be on the safer side, I would suggest don't go with only 2 points. Pick 5 to 6 points, identify those points on the coordinate plane, and then try joining them. If it's a linear equation, it will draw a straight line, which will go through all the 5-6 points that you have picked up. If it's a quadratic equation, it will form a parabola for you, like what we are seeing here. Okay. See, these points, by no means I could draw a straight line. I had to join them one by one, and then we saw that it's drawing parabola, right? So, plotting a graph on a coordinate plane, it's an easy thing. Just that you can have as many data points that you want to pick up. Don't go with 2 or 3 or 4. You can even go for 6-7 points, and then plot those points in the graph paper and join them. And you will by seeing the picture, you will know whether it's a straight line or it's a parabola or it's something else. Yeah. This is about graphing a function. Any question or doubt so far? And some of you who feel that this is an easy one, yes, I agree. This is an easy one, but this comes in the SAT exam as well. Yeah. Now the next one is isolating quantities. If you talk about isolating quantities, I will not take more than 2 minutes to talk about this, okay? Because this is the easiest of all the concepts that you guys know. Just that I am trying to cover the topic, that's why I am touching upon this one. But in summary, isolating quantity is a very important part of algebra. Whenever you are dealing with an equation or expression, you have to deal with similar things. Let's say you guys are all in this group because you are all preparing for SAT. Can I have you guys in the same class along with those toddlers or the junior kids from 3rd to 5th grade? No. You don't want to deal with unlike things, right? Things which are not similar in nature. So that's why you always end up isolating things or segregating things in a way that you deal with similar things together. Let's say if you have 5x minus 2y plus 17 equal to 3x minus 14y. If you are dealing with this, or if you are trying to solve this equation, your first attempt would be, what are the similar things? These are 5x, 3x. If I treat x as banana, this is 5 banana and this is 3 banana. I'll get all the bananas in one side of the equal to sign. Or I'll get them together at least. If this is apple, I'll get all the apples on one side, or at least get them together, so that I can say, okay, 2 apples plus 4 apples, 6 apples. I cannot say 2 apples plus 6 banana is equal to 8 banana or 8 apple, right? So that's all about this isolating quantities, okay? You bring similar things together So when you are trying to solve this equation, you will get this guy here, and you know that when you make this guy cross the equal to sign, plus becomes minus, minus becomes plus. So this is what it becomes, and plus 17, let's say, and then you have 2y here. If you want to get all the y's on one side, so this minus 2y becomes plus 2y minus 14y. So now 5x minus 3x becomes 2x plus 17 equal to 2y minus 14y equals minus 12y. So see again, these are things that you guys already know. I'm just telling you, when you have an equation like this, when you have to solve it or simplify it, this is the way that we go about it, and that technique is called isolating quantities. So I mean, before I started teaching my daughter, I was not knowing the terminology for this one. But isolating quantity, as you go by the English meaning of it, it says isolate them. And that is exactly what we do when we are dealing with algebra, when we are dealing with equations, right? So that is the conceptual part, that is how we relate. But I'll assume that you all know this, so I'm not going to deliberate further on this one, unless any of you say that, please repeat. Everybody is good? Yep, okay.
Yes, sir.
Alright, so let's move on. What is the next topic here? The next topic is linear and quadratic systems. So we have learned about the linear equation and we have learned about the quadratic equation also. Now, when we say linear and quadratic system, what does it mean? It means we have one equation which is a linear equation, and you have one equation which is a quadratic equation. And when you are trying to deal with them together, first thing that you will visualize, if you look at this in a coordinate plane, this looks like a parabola. So this will probably draw a parabola, something like this. I don't know whether this is correct or not, but this will draw a parabola for sure. Okay? And this is a linear equation that will draw a line. Now, this line might cross this parabola, or this line might not be friend with this guy and go this way without touching the parabola. Now, whether this will cross the parabola at any one point or 2 points, or it will not cross, that depends on when you try solving these two equations together. If you find some common value for x and y, if you find some common value of x and y, that is the point where it's meeting. Okay? If you don't find, that means there is no ways they will meet. Now, when I say whether it will cross or not, so there are two options that you have. You can just solve these two equations algebraically and find out the x and y value. If you find two values of x and two values of y, which is meeting both the conditions, that means the line is crossing this. If you don't find a common value for x and y, then you can assume that okay, they are not meeting, they have nothing in common. Okay, so that is one approach. Second approach is you literally make the tables for this one and table for this one for x and y values based on this contract, based on this contract. So you'll make two tables and you will plot those things in a coordinate plane and see if they are meeting anywhere. Okay, so I will just spend maybe 2-3 minutes to quickly solve this equation. But before I go further, is everybody with me so far? Everything okay? Understandable? Easy? Boring? Known? Unknown?
It was easy.
Easy? Yeah. Okay. Alright. So I have these two equations. I can draw on a graph paper, but this is a whiteboard I have. I don't have a graph paper right now. I'm using the algebraic method to solve this. So from this we find that the value of y is this and the value of y is this. Both the y are same, right? So that means if I have to find out if there is something in common, I would assume that these two y's are same. So substitute the value of y. This equals 6x plus 12. This y and this y I put in a common equation to see what it is. So that then we are doing isolating quantities, so getting everything together which is matching. So minus 13x, this 6x comes this side, so this becomes minus 6x plus 24 minus 12. So this becomes my new equation. So 2x square minus 13 minus 6, so 19x plus 12 equals 0. Now I have this equation to solve and find out the value of x. So since this is a quadratic equation, this can give me up to two values of x. If I have a linear equation, it can give me maximum any possible value of x and y, right? Basically, no, let me correct myself. If I have two linear equations like this and y equals to 3x minus 6, if I have two equations like this, both are linear equations, so when I solve them, I will get only one value of x and one value of y. Since I have a quadratic equation here and I have to solve it for this, I can get up to two possible values of x. So this relates to the theory, Dhanushri, if you want to relate this. If I have a equation or function, the number of values or number of solutions I can get for x, be it 0 or non-zero, will be equal to the maximum power of the variable. Okay, so there's just one concept that you can keep with yourself. Okay, I mean, what I'm trying to say is I have started studying that one, but it was very late by when I came to that topic. Okay, so but then the point is, if you have any equation, if you have a, let's say, your equation like 4x minus 13 equals to 0, this will give you one value of x. If you have a quadratic equation like this can give you up to two values of x. If you have an equation like 3x cubed minus 12x squared plus 16 minus 66 equals 0, this can give you up to three values of x. This defines the rule, saying, okay, depending on the number of power you have, you can have that many possible values of x. Okay, this is the fourth method of telling you guys that, okay, just go by the power and you can assume. But then if you look at it, if you think about it a little further, eventually what will happen is, when you factorize this, you'll have three factors like this. When you factorize this whole equation, equation with power of 3, this will break down to three factors like this. So that is why this one gives one value, this one gives one value, this one gives one value. So that is the reason for relating it to that way. So if you, whatever is the number of power, that many factors you will eventually end up having in your equation. Okay, when you break it down. Yeah. So now coming back to this one. So when I have a quadratic equation like this, there are three ways to solve it. 2x squared, this is my equation now. 2x squared minus 19x plus 12 equals 0. I have three ways to solve this equation. Who all remembers all those three methods? Just tell me the method. I will do it, but anybody who remembers all the three methods? Yes, Vaibhav.
Quadratic formula and factorizing.
And then relating that with one of the basic a plus b whole square, a minus b whole square kind of a method.
A plus b,
So Neil and Sarah, you were not in the class, but see, when I have a quadratic equation to solve, there are three ways of solving it. One is called a quadratic formula, where from this you can simply say x will be equal to minus b plus minus b square minus 4ac by 2a. Yeah, this is one. So here, this is a, coefficient of x squared is a, coefficient of x is b. So this is a standard form, ax squared plus bx plus c. This is a standard form for a quadratic equation. So here if you see, a is 2, b is minus 19 and c is 12. And you can just substitute the value and find out the value of x. This is one approach. Second approach is where you try factorizing it. But before you try doing it, there is another way. since you see this in a square plus bx plus something, right? This also, we also know the rules. A plus b whole square equals a square plus 2ab plus b square. A minus b whole square is a square minus 2ab plus b square, and a square minus b square equals a plus b into a minus b. But here, so you try relating with this formula. So do you see any correlation? Probably not. Just in the interest of time, I'm not trying to factorize this also. What I will do instead is, I'll just substitute the value here so that we can solve this quickly. So here, but yeah, Neil and Sarah, were you able to, were you aware of this quadratic equation solution approach before, or is something new to you?
It's new to me.
Okay, so then let's do one thing. So Neil and Sarah, I'll wake you guys up a little bit early on next Saturday. Saturday at 8:30, I have a class for the kids who are joining in between. So I'll walk you guys through the three methods of solving a quadratic equation. Okay, next Saturday if you can wake up a little early, 8:30,
Okay.
8:30 to 9, just half an hour. Okay, yeah. And here I don't remember if you were part of that class as well. So if you can join for 30 minutes, I can walk you through
Sorry,
it.
I was there.
You were there.
Yes.
He doesn't want to wake up early on a Saturday, and she has a reason for it. No, I'm just kidding. So yeah, that's fine. So that's a complimentary class for you guys, so that anything that we have learned in the past and something very generic in nature, we can use that class for kind of covering it up. Yeah. All right.
Okay.
Yeah. All right. But here, when I have a quadratic equation, the standard form of a quadratic equation is like this. So here you can see A is 2, B is minus 19, and C is 12. We'll put the value of this in this equation to be able to get the possible answers for x. So x becomes minus b, minus b, minus b. B is how much? Minus 19. Plus minus b square minus 4ac. B square is 19 square. 19 squared will be 19 9 171. 17, 19 plus 17, 36. 361. So 361 minus 4ac. 4 times A is 2 times C is 12. So by 2A, 2 times 2. So this becomes minus 4 plus 19 plus minus B squared. 361 minus 4 2 is 8 and 12. 12 8 is 96. 361 minus 96 by 4. And once you solve this, you get two values of x, one with a positive scenario, one with a negative scenario, and then for the corresponding value of x, you can find the value of y for the corresponding value of y for each and every x, and that will help you solve this one. So again, going back to what we were trying to do, we had one linear equation and we had a quadratic equation. We were trying to find out, do we have some solutions by using these two equations? Meaning, are there points where these two graphs, the parabola and the line, will meet? Without plotting the graph, you were trying to solve it for x and y, and once we get the value of x and we will get corresponding two values of y, those 2 points become the point of intersection. Okay, so then without plotting also, you would know that okay, this line is meeting this parabola at two places, where one place is x1 y1, meaning the one value of x that we'll get by using the plus part of it, and then corresponding y, and then x2 y2. Okay. So when we talk about linear and quadratic systems, essentially what we are talking about, we talked about linear equation and we talked about quadratic equation. It was more of a combination of both, which says when I have a linear equation and when I have a quadratic equation both, how do I deal with them? How do I interpret? How do I try finding where they meet, how they deal with each other. So Sammy, you are 5 minutes early, beta. Let me finish the class with the elder ones and then we'll start your class. Okay? Alright. So this is all about the last but one topic, which is linear and quadratic systems. Okay? Any questions so far? At least with the approach part of it. I know when we do some sums, it'll make it more. It'll make you guys more comfortable with the concepts. But apart from that, whatever we have learned so far, are you guys able to follow me? Is this understandable? Complicated? How is it? Okay. See what's up is fine.
It's easy to understand.
Easy to understand. Yeah, you guys are already tired of hearing the same thing a couple of times, and that is my intention also. I will make sure that I teach you guys the concept enough number of times that when you see the question, you will laugh at the person who has said the question for you. I mean, obviously you'll do it as well. Yep. All right. So then we move on to the. Okay, I think we should not be moving on to the next topic. Otherwise, you will see a lot of younger kids peeping through the window. Yeah. So next, our last topic in today's plan was radical, rational, and absolute value functions, and that also we have dealt with in the past. But just to give you a very high level view of that, functions we have seen. Functions we have seen. We have seen y equals to 2x squared plus 6x minus not 7. Okay, 18. This is a normal quadratic function. It gets interesting if I say y equals to 2 into x to the power 1 by 2 plus 6 x to the power 1 by 3 minus 12. This is where you see and a function or an equation with power to the variable as a fraction. That is where it is called rational value function. Or let me not what is that?
Square root of x and third root of x.
Yeah. This is square root of x. This is third root of x. So we'll talk about this, in the coming class. We'll touch upon this concept. We'll not take more than 10 minutes to cover this one. So this will be just a part of the other topics that we'll learn in the next class. Okay. So I'm just trying not to rush through it so that we learn it and then we realize that we have not learned it. Yep. Where's your notebook?
I want to do the trampoline.